Now we're ready to get started on chapter 6. So in chapter 5, we looked at solving systems of equations and systems of inequalities. Some are linear, some are nonlinear. So now we want to look at chapter 6, which is solving systems of linear equations using matrices. So first, let's define the concept of a matrix. So a matrix, I have a couple examples there already, is just an array of numbers. And the array of numbers is arranged in rows and columns. It's always row by column. And so we describe the rows and columns as it's always a row first. So M by N is how we usually describe it. So you have M rows and N columns. So it's M by N is how we describe that. If they're the same, then we call it a square matrix. So this one here is an example of a 3 by 3. So you have your entries 1, 2, usually go across in rows. So you go 1, 2, 0, 5, 6, 8, -1, 7, 3. 1, 2, 3, 4, 5, 6, right? So that's a 2 by 3 matrix, etc. So that's what the matrix looks like. So what we're going to do is set up a system of equations and then use that same format to describe like X, Y, and Z. So that's the idea. So this is our goal next, is to solve a system of linear equations, but instead of using the equation form, it'll be in this matrix form. So that's what we're after. So solve by elimination. So let's do this first. So we're going to solve by elimination, and then we're going to use a matrix. We're going to do 2 columns and see what that looks like. All right, so suppose you had the system x minus 2y equal to -1, 4x minus 7y equal to 1, and then what we're going to, so I'll do it kind of at the same time, we'll do the matrix. So write in those coefficients, right? So 1, -2, and then -1, 4, -7, and 1 over here in the matrix form. So it'll be 1, -2, -1, 4, -7, 1. And we put those dots like that because we call that basically the coefficient matrix. So what we have is this coefficient matrix and then the constants, and we call that an augmented matrix. So then you put in brackets like this. And so we'll call this equation 1 and equation 2. So we're going to call these a row 1 and row 2, like that. That's how we're going to do it. So first thing we can do when you're looking at this system is we can interchange the equations, and it isn't going to affect anything. So one thing, and I'm just going to kind of show you the steps we can do and what may or may not work. So to help, actually, we've interchanged those like that. So if we interchange, we get 4x minus 7y equal to 1, and x minus 2y equal to -1. So that's just interchanging equations. Okay, so interchange equations. So over here, what we would say is we're going to swap row 1 and row 2. So we'll do it like that. So it'll be 4, -7, 1, 1, -2, -1. All right, so you have that. Now we're going to do operations on the equation to eliminate the variables. So we can see here, the best thing to do, nice thing to do, would be eliminate this x by multiplying equation 2 by -4. All right, so let's do that. So we're going to say equation 1 doesn't change, so 4x minus 7y equal to 1. And then we're going to say -4 equation 2. So you get -4x plus 8y equal to 4. All right, so over here, it's just you recopy row 1. So 4, -7, 1. And then we'll say -4 row 2. And so you put in -4 row 2. So you multiply by the row 2 by -4, and you get -4, 8, and 4. And you can see how they're matching. So there's really the same thing. Then over here, you're going to add them up. You're going to say equation 1 plus equation 2. And I'm going to show you this part. You're going to recopy row 1 because you want to kind of keep it together as one system. When you do that, you get y is equal to 5. So y is equal to 5. Over here, it's the rows. So you recopy row 1, 4, -7, 1. And then you just do row 1 plus row 2. And you'll get 0, 1, and 5. So they really mean the same thing between this system and this system. It's just a different format. So from here, what you would do is you'd back substitute to solve for x. Right, so you get 4x minus 7 times 5 equal to 1. So you get 4x minus 35 equal to 1. 4x equal to 36. And so x is equal to 9. So that's exactly what you're doing for this. So that means the same thing. So these two here is what you would write when you do your back substitution. So that already tells you that x is, or not x, sorry. That already tells you your y is equal to 5. And then you'd back substitute, just like that. And so from there, you have your y and your x. So your solution set is the ordered pair, a unique solution, 9, 5. Okay, so let's get into what we call the elementary row operations. So all of those processes we just did are called elementary row operations. All right, so the elementary row operations, what we want to describe. So it's everything we can do to those equations, we essentially can do to those rows and not change the solution to the system. So what we can do is interchange rows. You can do a constant multiple times a row, right? Both sides by the same thing. And you can, I don't think I'm liking that. You can add rows. So you basically multiply by a constant and add rows. So multiply by a constant and add rows. So those are the operations you can do to the system. So this method, let's look at this example, is called Gauss-Jordan elimination. So solve the system using Gauss-Jordan elimination. And we'll say to row echelon form, and I'll describe what that means. So row echelon form I'll describe. So that essentially means you get a 0 down here, and it'll be a lower triangular zeros for the other case of a 3 by 3. So suppose you had this system, y minus 3z equal to negative 5, 2x plus 3y minus z equal to 7, and 4x plus 5y minus 2z equal to 10. So our goal is to, well, the first thing you do is you write that in a matrix form. and putting in your placeholders. So it would be 0, -3. No, sorry, 1, -3. 0, 1, -3, -5. 2, 3, -1, 7. 4, 5, -2, 10. So that's your matrix. And then you perform the elementary row operations to solve the system. Don't like what that's doing. To solve the system. Okay, so go ahead and pause here, and then we will finish that and do a couple more, because it does take a while. So if you want to get started and maybe try it, go ahead, but otherwise we'll work on it together.